Okay, example 5, we have a chart. Okay, we have an original chart up here. So this is the original function, and we have a derivative chart. And the question is asking, what are the critical points of f of x? So you might be thinking, well, how can we do this? I mean, it's just a chart. Well, we do have a derivative chart, and that's the key. We can tell where the derivative equals 0 and where it doesn't exist straight from this chart. So the derivative equals 0 at 5, and the derivative doesn't exist at 9. Furthermore, we have the original function to tell us what the points are. So we can see that there's going to be a critical point at 5, 5, because at the derivative it equals 0. Okay? We can also see there's going to be a critical point at 9, 1, because the derivative doesn't exist at 9. Okay? So I've pretty much just done the problem, but let's go through the steps. When we take the derivative, we just focus in on that derivative chart for step 1. For step 2, when we set the derivative equal to 0, well, we just hone in on the point where the derivative equals 0. So there is a critical value at 5. Okay, so there's our first critical value. We also look for step 4 to see where the derivative doesn't exist, and that's at x equals 9. So guess what? That's our next critical value. And again, that's because the derivative doesn't exist. That makes it a critical value. So we have two critical values, x equals 5 and x equals 9. Step 5, we just write those values out. Step 6, we determine the critical points by plugging it back into the original. So the original chart they gave us, just the original f of x, since there's a critical value at 5, we just look at the y value. So our first critical point is 5, 5, 5. The second critical value, plug in x equals 9, we get 1 back for the original. So second critical point is 9, 1. And now we're just going to write those points out. First critical point is 5, 5. Second critical point is 9, 1, and that completes this. Now we can't really graph this, right? Because it's just a bunch of points with a bunch of different values on the derivative. But we can be sure, because we looked at the derivative and where it equals 0 and doesn't exist, that these are our critical points for this particular function. All right, that's it for this example. If you have any other questions about it, let me know.